Alright, in the last video, we talked about complex numbers and we just worked with them in number form. We had expressions where we saw the square roots of negatives. We also saw expressions where we had things in terms of I, and we talked about simplifying, adding, subtracting, and multiplying them. Okay, so that's fine. You know, we have these numbers, we play around with them, but why do we have these numbers? Where do they come from? And so in this section, we are going to talk about solving equations in the complex number system. All right, so let's go ahead and look at some examples. All right, so complex numbers come about from solving quadratic equations. And so when we talk about solving quadratic equations, remember that we could solve using factoring. We're not going to be playing around with factoring in this section because remember this comes from square roots of negatives. We never see square roots when we talk about factoring. And so what we're going to be using in this section, in order to solve quadratics in the complex number system, where do we see the square roots? Well, we see square roots when we talk about the quadratic formula. Obviously, we see them when we talk about the square root property. We also see them when we talk completing the square. And so we're going to go ahead and look at some equations and talk about, okay, what would be the best strategy? Remember that technically between quadratic and formula and completing the square, we can do either one of these. Okay, but I do want to do a little bit more practice with completing the square. And so we'll talk about examples where completing the square will be a good option. All right, so let's go ahead and come down to our examples. Our first one, we have x squared plus 5. And so this one, we can think of this as doing completing the square, or really this is just a square root property problem. The first thing, remember when we talk about using the square root property, the first thing we want to do is isolate the squared thing. So on the left side, anything outside my squared thing, I want to move to the other side. I'm going to go ahead and subtract 5 from both sides. We get x squared equals negative 5. And then we can go ahead and take the square root. We have our squared thing is isolated. We take our square root. On the left, my square root and my square cancel, leaving me with x. And just like we saw in the last video, remember that all we're going to do is whenever we have this negative inside the square root, we're going to pull it out. And then we want to try to simplify the square root. But this one does not simplify, so we're just going to leave it as I square root of 5. We also need to remember, what do we have to do whenever we take the square root of both sides? We have to have plus and minus. And so my final answer is going to be x equals plus or minus I square root of 5. And we're done. All right, let's look at a couple more. Let's come over to example B. This is also set up for square root property. And so we can go ahead and isolate our squared thing. We want to move everything that's outside to the other side. So I'm going to start by adding 49. We get negative x squared equals 49. And then I also need to get rid of the negative here. So I'm going to divide by negative 1. We get x squared equals negative 49. Since we have our squared thing isolated, I can now go ahead and take the square root of both sides. On the left, my square and square root cancel, leaving me with x. We did take the square root, so I do want plus and minus. If we ignore the negative for now, if we take the square root of 49, we get 7. And we want to bring the negative out as an I. And we're done. All right, so those two were set up for square root property. The rest of these we're going to either use completing the square or quadratic formula. And so the reason is, if we come over to C, we can't really isolate our squared thing because it's not just x squared anymore. And we got other terms running around, and so we do need to go ahead and use either quadratic formula or completing the square. Now for me, as I said, I do want to practice completing the square as much as possible. And I'm going to say this is a good candidate for completing the square. And the main reason is because my middle number is even. We're not going to have to worry about fractions. So remember, in order to complete the square, we want to start by getting my x's by themselves. We want to move our constants to the other side. We get x squared plus 2x. I'm going to leave a space, and then I'm going to have my -4. All right, so when we do this, we're going to look at this middle number. I want to divide by 2. We get 1. And then I want to square the 1, and, well, we also get 1. And so I am going to add in a +1 on the left, and we also want to do it on the right. All right, if we go ahead and factor the left side, we have x squared breaks down to x and x, so I'm just going to put an x. The only way to break down 1 is 1 and 1. And then because my middle number is positive, this is going to be x plus 1 squared. On the right side, when we combine, we get -3. And now we can go ahead and take the square root. We take the square root of both sides. We get x plus 1. Because we did take a square root, we do need a plus or minus. If we look at square root of 3, it does not simplify, so I'm going to leave it inside. And then because I do have a negative inside my square root, I'm going to bring out an I. In order to finish solving for x, we want to subtract 1 from both sides. And we get x equals -1 plus or minus I square root of 3. All right, that takes care of that one. Let's look at a couple more. All right, if we come down to example D, technically you could solve this using completing the square, but for me this is not going to be a fun one. And the reason I don't want to do completing the square on this one is because my middle number is odd. And so I'm going to go ahead and solve this using quadratic formula. Remember that unless it specifically says solve using blah blah blah, you can use whatever method you want, okay? So we're going to go ahead and do quadratic formula. I want my A, B, and C. The number in front of x squared is just a 1. the number in front of x is 3, and my constant term is 5. All right, if we go ahead and plug this into our quadratic formula, we get negative b plus or minus the square root of b squared minus 4 times a times c over 2a. And when we plug in, we get negative 3 plus or minus. If I square b, I get 9. And if I do 4 times a, we get 1, times 5, we get 20. And we're going to put all of this over 2 times 1, which is just 2. All right, we go ahead and finish simplifying our square root. We get 9 minus 20 is negative 11 over 2. Square root of 11 does not simplify, but we do still have that negative on the inside, and so we just want to bring it out. So we are going to get negative 3 plus or minus I square root of 11 over 2. And I'm going to leave it like that, okay? All right, let's look at the last two. Let's come over to E. One of the first things you may notice is we have a leading coefficient of 1/2, and I really don't like that. And we technically don't have to work with it. Because we are solving equations, remember that we can multiply by numbers in order to cancel denominators. The first thing I'm going to do is I am going to multiply this whole equation by 2. If we do this, if we multiply 1/2 times 2, I get x squared. If I multiply 17 times 2, I get 34. And if I multiply 5x times 2, I get 10x. For this one, I am going to go ahead and use completing the square. The main reason is because my x term, that is even now. And so I want to rewrite this. Remember, we want all of our x's on one side. We want all of our constants on the other. And what we get is x squared minus 10x, leave a space, equals negative 34. All right, to complete the square, we're going to take our negative 10. We want to divide by 2, we get negative 5. And then if we square negative 5, we get positive 25. So I will go ahead and add that in on the left and the right. All right, we can now go ahead and rewrite the left side as something squared. And this is going to be x. 25 is going to turn into a 5. And because we do have our middle number is negative, it's going to be a minus 5. On the right side, when we combine, we should get negative 9. All right, we can now go ahead and take the square root of both sides. On the left, we are left with x minus 5. We took a square root, so I do want plus and minus. We have the square root of 9 is 3. And again, we do have that negative. And so I am going to pull it out as an I. All right, and then finally, to solve for x, we want to add 5 to both sides. And we get x equals 5 plus or minus 3i. And we're done. One of the questions that someone asked in class the other day was, why don't we write it 5 plus or minus I3? And it's really not the I that we care about in terms of the order. It's more the square root. Remember that over here, if I rewrote this as square root of 11i, depending on how careful you are or how sloppy you are, sometimes this can look like the I is inside the square root. This is the main reason that we do like to write the I in front or anything in front of the square root, is so that there is no question about whether something is inside the square root, or no question about what's inside the square root and what's outside. Even though, if I go back and erase this just a little bit, even if I do this and it's very clear, okay, this would be considered acceptable, okay, as long as it's clear that the I is not inside the square root. But just like with our variables, we don't like to write x3. We always like to have our numbers in front. And even though I is not a variable, we do still have kind of the same, it's visually easier to read if we have the number in front of the I, as long as it's a nice number. All right, let's go ahead and continue. We got one more example to look at on this slide, and then we'll be done with this slide. All right, let's come over to example F. Okay, example F, we have 4x squared equals x minus 1. And for this one, I want to do quadratic formula for two reasons. Okay, we do not have, our x term is not an even number. We also have this leading coefficient, and that makes completing the square a little bit more challenging. And so we might as well go ahead and do quadratic formula. I'm going to go ahead and move everything to one side of my equation. We get 4x squared minus x plus 1 equals 0. We're going to let a be 4. That's my number in front of the x squared. B is going to equal negative 1. It's my number in front of the x. And C is going to equal 1. All right, so when we plug in, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. When we plug in, we get minus negative 1 becomes plus 1, or positive 1. We have plus or minus. If we square negative 1, remember whenever we square something it becomes positive, and we get minus 4 times 4 is 16, times 1 is still 16. We divide by 2a, and so we get 2 times 4 is 8. All right, if we go ahead and simplify this now, we get 1 plus or minus the square root of negative 15 over 8. Square root of 15 does not simplify, and so we are just going to bring out our negative. We get 1 plus or minus I square root of 15 over 8. Now, one of the things to notice here is notice that, and we'll talk about this in the next slide, but notice here on all of these problems, whenever we have complex, non-real complex solutions, whenever we have imaginary answers, notice that they all come in pairs. We have, for our first one, we have plus or minus I square root of 5. That is technically 2 answers. The second one, we have plus or minus 7i. That is 2 answers. And so when you start off with real numbers in the problem, which that's what we're always pretty much going to be given, as long as you are starting with real numbers in the problem, your imaginary solutions will always come in pairs. You will never have one real solution and one imaginary solution. It's just not possible. Okay? All right, so that's one of the things to keep in mind as we look at the next slide. All right, the last thing that we're going to do is we are going to go ahead and try to use graphs in order to predict real zeros and how many, as well as non-real zeros. We then want to find the zeros algebraically. All right, so if we look at example A, remember that the number of real zeros corresponds to the number of intercepts. If we look at this problem, we have 2 intercepts. We have one here and we have one here. Another thing that I notice about these is one of them is definitely a nice intercept. I see an intercept of -1, and this tells me that this thing is factorable. And so if we want to solve this, remember we're going to set this equal to 0. And as I said, we should be able to factor it. So 2x squared, this breaks down to 2x and x. We'll get into this a little bit more later, but because I do see that I have a nice intercept at -1, it does not have a denominator. I'm going to put my 1 with the x, and I'm going to put my 3 here. In order to end up with a negative on the inside, I want my larger quantity to be negative, and so I see here my outsides I've got 2x. My insides I've got 3x, and so I want my negative with the 3, my positive with the 1. If you do go ahead and FOIL this, you should see that we get 2x squared, we're good. 2x minus 3x, our outsides and our insides, do combine to -1, and we get our -3 times our +1. Our last gives us -3. All right, if we go ahead and set each factor equal to 0, for the first one, we can add 3 to both sides. We get 2x equals 3. And then when we divide by 2, we get 3 over 2, which is equal to 1.5 or 1.5. And that's actually what we do see right here. For my second one, we subtract 1 from both sides. We get x equals -1. And so what we have here is we have 2 real zeros. All right, the next one, let's see what we can do. Example B, when I look at this, I see 1. To me, it looks like this is touching the x-axis. And so what that means is this is actually factorable as well. It may not look like a nice number, but because it is 1, I know that my factors are going to be exactly the same, which means that this is going to be a perfect square trinomial. In order to solve this, the first thing that I want to do to make it a little bit easier so it doesn't give me too much of a headache, is I'm going to start by dividing everything by -1 so that my leading coefficient is positive. You don't have to do this, but it makes it easier for me. And so we want to change all the signs. So I'm going to go x squared minus 4.6x plus 5.29. So as I mentioned, because we only have one x-intercept, we are going to go ahead and factor this, and it is a perfect square trinomial. So if I break down x squared, that's going to be x and x. I want to know what squared is equal to 5.29. And if you take the square root of 5.29, you should get 2.3. You can also use what we were doing earlier when we were completing the square. It should also be equal to half of the middle number. And so we get x minus 2.3 squared. You can take the square root of both sides, or you can just take one of these factors and set it equal to 0. We can add 2.3 to both sides, and we get x equals 2.3. We have one real solution. We have one x-intercept. And later this semester, in the next module, what we call this is called a repeated zero, or repeated solution. And we call it repeated because how many times does it occur? Well, because we do have our factor occurs twice, we repeated it. All right, let's come down to the last two. All right, for example C, we have no x-intercepts. So no x-intercepts means no real solutions. And as I mentioned on the last side, what that means is we have two non-real complex solutions. So in order to find these, we either have to do completing the square or quadratic formula. Because I'm going to go ahead and set y equal to 0. Because we do have this coefficient here, I'm going to go ahead and do quadratic formula. And so we have a equals -2, we have b equals +2, and c equals -3. If you want, you can also divide by the negative so that you don't have to worry about a negative in the denominator. All right, if we plug in, we get x equals -b plus or minus the square root of b squared minus 4ac over 2a. And when we plug this in, we get x equals minus 2 plus or minus the square root. If we multiply, if we square b, we're going to end up with 4. I am going to do minus 4 times negative 2 gives me positive 8. And if we multiply that by negative 3, we get negative 24. All over 2 times negative 2 is negative 4. All right, if we finish simplifying inside the square root, we get the square root of negative 20 over negative 4. We haven't done this today yet, or in this video. We do want to break down square root of 20. And so square root of 20, this is square root of 4 times square root of 5. We get 2 square root of 5. If we bring that back over, we get negative 2 plus or minus 2 square root of 5. And I'm going to bring out my negative as an I. We have this is over negative 4. And then I want to simplify. So here you can divide by 2, but I also don't like the negative in the denominator. Mathematicians don't like lots of things in the denominators, and one of the first ones is negative. And so what I'm going to do is all of these terms I want to divide by negative 2. If we do that, we get negative 2 divided by negative 2 is 1. My plus and minus is basically going to flip-flop. So if it's positive, it's going to turn negative, and if it's negative, it's going to turn positive. So we still have a plus and minus. If we divide 2 by 2, we get 1. And you don't have to write it here just because we got more stuff in that term. We still have our I square root of 5, and so we can just write this as plus or minus I square root of 5. And then finally, we want to divide the denominator by negative 2, and we get positive 2. And we're done. Okay, and so notice here that we have 2 non-real complex solutions. We have 1 plus I square root of 5 over 2, and we have 1 minus I square root of 5 over 2. All right, let's come to the last one. This one, we also have no x-intercepts, which means no real solutions. So we are going to have 2 non-real complex solutions. All right, I'm going to go ahead and set my equation equal to 0. For this one, again, I don't want to do completing the square, mostly because I don't have a middle number in the middle term. I don't have an even number in the middle term. So I'm going to go ahead and use quadratic formula. So we have a equals 1, that's the coefficient of our x squared. We have b equals negative 1, that's the coefficient of my x term. And we have c equals 1, which is our constant. All right, if we plug this into quadratic formula, we get x equals minus b, this is going to be minus negative 1, becomes a positive 1. If we square b, we get negative 1 squared is 1. We get minus 4 times 1. 4 times 1 is 4. Times 1 is 4. Or negative 4. And then we get 2 times 1 is 2. All right, if we finish simplifying inside our square root, we get 1 minus 4 is negative 3 over 2. Square root of 3 does not simplify, but we do have that negative there that we can go ahead and bring out, and we get 1 plus or minus I square root of 3 over 2. All right, that takes care of solving in the complex number system. And that's pretty much going to finish up our discussion on quadratics. We've been doing a lot with quadratics in these past 4 sections. The next section that we are going to look at is another new topic, and we're going to be doing graphing and talking about transformations. All right, I will see you again soon. Thank you.